All right, guys, today we're going to talk about bisection. The root word of bisection starts with bi, and if you think about the word bi, a bicycle has two wheels. Bipolar means two polarities, north and south. Bi, root word, is two. So when we talk about bisecting something, we are dividing it into two congruent segments or angles. So bisect means to divide something into two. So if we take a line segment, for example, so we look at line segment AC. Remember, it's a segment, not a line, so it has a start and an end. If we bisect it, we are going to divide it into two congruent parts. So line AB is congruent to line segment BC. But definitions can be reversed. So sometimes we're not given a line segment and asked to cut it into two pieces. Sometimes we're given two congruent pieces and asked if it has been bisected. So sometimes we'll know that AB is congruent to BC and have to conclude that B bisects AC. It's going to be important that we understand how to make these kinds of conclusions in our next few topics as we begin to write proofs. So to recap that, when it talks about line segments, we can bisect both ways. We can either have a segment be bisected. So in this case, we have line segment AC is bisected by point B. So by putting point B here in the middle, I've created two congruent line segments, AB and BC. In the reverse of that, I could be given that AB and BC were already congruent, like we have down here, and then my conclusion would be that B bisects AC. So here we're given an example. We're given the length of XZ. Notice that in my notation on XZ right here, I do not have the line segment symbol on top of it. If I don't have a line segment symbol, then I'm referring to the line segment as a distance. I'm talking about an actual valid number. So XZ has a distance from X to Z of 12. I might write that on my picture like this. Then I'm given that Y bisects XZ. So I would denote that on my picture by making two congruent symbols. Now I'm given that XY is equal to A plus 3. So I would write A plus 3 here. Now if I know XY is equal to A plus 3, then I know that YZ is the same because they are congruent. That's what my little tick marks right here mean. Congruent, congruent. So that means that YZ is also A plus 3. With this kind of information, I can write an equation. My equation would be that A plus 3 plus A plus 3 is equal to 12. Now I just solve my equation. I get 2A plus 6 is equal to 12. I subtract 6. I get 2A is equal to 6, and I divide by 2. And I get that A is equal to 3. Now I can plug that back in. 3 plus 3, 3 plus 3, I get 6 and 6, so it checks out. I can do this same idea with angles. If we talk about it in terms of angles, the really important thing here, if I'm talking about angles, is to know where the vertex is and to make sure that I notice when I'm talking about each different angle, which angle that means. So for example, ADC is this big angle right here, ADC. So if I were going to highlight that, I would go A to D to C, A to D to C. So that would tell me angle ADC. And angle ADC in this picture is 40 degrees. Then I'm being told that DB trisects ADC, and DB is a ray. So I go up here and I look at ray DB. So it starts at D and it goes through B. and it bisects angle ADC, which means it divides it into two congruent segments. So I have two little segments here that are each the same. So when it asks what is the measure of angle ADB, well, now I'm looking for, well, where is angle ADB? Angle ADB is ADB right here. So that angle should be half of ADC, and half of angle ADC would give me 20 degrees. So the answer here should be 20 degrees.